Welcome to this explainer. Today, we're diving into the ultimate roadmap for backend development. If you've been following the evolution of the modern web and you're looking for a really structured view of how all the pieces of the ecosystem fit together, well, you are in the exact right place. We're going to take what can honestly feel like a crazy, tangled landscape and transform it into a clear, logical, and linear architectural journey. So, let's just jump right in.
Here is our roadmap for today. We'll be hitting the foundation and data, APIs, frameworks and security, system design at scale, DevOps and cloud deployment, and finally, advanced engineering and operations. Before we get completely lost in the technical weeds, I want you to just think about scale for a second. When a modern system processes millions of concurrent transactions literally instantly, what kind of architecture is actually carrying all that weight? I mean, while users are busy interacting with these perfectly polished interfaces, there's this massive, highly optimized operation happening completely out of sight.
That hidden operation? That's the backend. You can think of it as the central nervous system of any application. It's doing all the heavy lifting. It stores the data, strictly enforces the business logic, manages those complex authentication states, and coordinates with distributed databases. Basically, it handles the chaos so the front-end experience stays perfectly seamless and responsive.
All right, let's kick things off with Section 1, the foundation and data.
Before you build anything, you've got to choose your tools, and your ecosystem really matters here. Python and JavaScript, specifically using Node.js, are fantastic. They offer massive library support and let you develop incredibly fast. But if you're building something that needs absolute, uncompromised enterprise-level horsepower, you're probably going to reach for Java or Go. Oh, and PHP? It's still a massively deployed foundational language across the web. Honestly, it's all about picking the right architectural tool for your specific job.
But it's not just about the languages, right? You have to understand the basic internet plumbing too. We're talking about managing persistent state, DNS routing, and the really deep nuances of the HTTP request response cycle and status codes. And crucially, utilizing version control with Git to track your code's history and collaborate on platforms like GitHub or GitLab. Yeah, that is entirely non-negotiable if you want to deploy with any kind of integrity.
Now here's where it gets really interesting. Data storage. This is your classic architectural trade-off. As developers, we're constantly weighing the rigorous, highly structured nature of relational SQL databases, Bank PostgreSQL or MySQL, against the fast, horizontally scalable, schemaless vibe of NoSQL options like MongoDB or Redis. It really is the ultimate battle of rigid relational structure versus raw developmental flexibility. But hey, regardless of which way you go with your database, mastering core design principles is exactly what's going to save you from those dreaded 3 a.m. database timeout alerts. You've got to understand normalization to organize things efficiently, use proper indexing to speed up read operations, and lock down your transaction management. These are the absolute building blocks for reliable, high-performance storage.
Moving right along to Section 2, APIs, frameworks, and security.
So how do we get all that persistent data over to the front end? We build APIs. And this actually brilliantly illustrates a huge architectural shift we're seeing right now. REST is still the stateless, super consistent industry standard, but GraphQL is this incredibly powerful modern alternative. It actually lets the client request the exact specific data it needs, which completely eliminates that painful latency you get from overfetching.
Look, the reality is, modern engineers rarely write repetitive server code from scratch anymore. Server frameworks are a total game changer. They abstract away all that boilerplate, so you can just focus on your business logic. Whether you like the minimal flexibility of Express and Node, the heavy-duty batteries-included feel of Django, or the pure enterprise power of Spring Boot for Java, leaning on these tools is going to drastically accelerate your deployment cycles. Okay, next up, we have to secure the perimeter. Failing to set up robust authentication like JWTs or OAuth 2.0, or forgetting to cryptographically hash your passwords with something like bcrypt, that's exactly how a really promising app becomes tomorrow's top data breach headline. Locking down your app against SQL injection, CSRF, and XSS is, without a doubt, a back-end developer's most critical responsibility.
All right, Section 3, system design at scale.
When things start getting really big, architects face a massive paradigm shift. Do you keep your code as a single unified monolith? I mean, it's super easy to start, but notoriously rigid when you're under massive load. Or do you pivot to microservices? Breaking an app down into small, independent services gives you unbelievable scaling flexibility. But, and it's a big but, it introduces a ton of operational complexity.
So how do you stop all those distributed microservices from instantly bottlenecking each other when traffic spikes? You decouple them using message queues and event-driven architecture. Tools like RabbitMQ or Apache Kafka let your services communicate entirely asynchronously. It's a lifesaver that drastically improves your system's overall performance and resilience. That brings us to another absolute essential for scaling: caching. By setting up a lightning-fast in-memory data store using Redis or Memcached, you can dramatically cut down database latency. You're basically creating a shortcut to serve up your most requested data almost instantly, so you aren't constantly hammering your primary database. And to make sure your app actually stays online during those massive surges, we use load balancing. Think of a load balancer as the ultimate traffic cop. It perfectly distributes incoming user requests across multiple servers, so no single machine ever gets overwhelmed. If you want zero downtime deployments, this is how you do it. Which leads us perfectly into Section 4, DevOps and Cloud Deployment. In modern architecture, automating your delivery pipeline is the name of the game. CI/CD pipelines are absolutely crucial here. The second a developer pushes a commit, boom, it triggers a whole cascade of automated tests. If it passes, it goes straight to production. This setup lets teams move incredibly fast while completely removing human error from the release process. Now, all that freshly tested code sits on a really solid Linux foundation. To make sure the app runs the exact same way on your laptop as it does in production, we package it into Docker containers. And when you're operating at true scale, you've got thousands of those containers being orchestrated by Kubernetes for automated self-healing, all hosted globally on cloud giants like AWS, Google Cloud, or Azure. And finally, we hit Section 5, Advanced Engineering and Operations. Once a complex system is actually live in production, the game totally changes. This is where senior devs really polish the engine. We're talking about getting absolute visibility into your system using observability stacks like Prometheus or Datadog. It's about rigorous end-to-end testing, adding live updates via WebSockets, or even pushing the envelope with serverless functions like AWS Lambda. There's a quote from our source material that I absolutely love because it just perfectly sums up this whole professional journey. Backend development is a craft, and like all crafts, it deepens with practice, curiosity, and the willingness to break things and learn from them. I mean, that hits the nail on the head, right? Mastering the backend really is this continuous, awesome journey of building real systems and learning from every single challenge you hit along the way. Wow, we have covered a ton of ground today, from the basics of core data structuring all the way up to global cloud orchestration. Now that you've got this complete, structured map to navigate the modern backend universe, the only provocative question left to ask yourself is, what are you going to build first?